The joint density function of two random variables x and y is given by f of x comma y is equal to 6 by 7 into x square plus xy by 2, where 0 less than or equal to x less than or equal to 1, 0 less than or equal to y less than or equal to 2. Compute the marginal probability density functions of x and y. Find e of x and e of y. Find p of x less than 1 by 2, comma y greater than 1 by 2. Let us find the marginal density function of x. Marginal density function of x கண்டுபிடிக்கணும்னா we have to integrate the joint density function with respect to y. So fx of x is equal to integrating the joint density function is 6 by 7 into x square plus xy by 2 dy, where the limits for y is from 0 to 2. Let us integrate this with respect to y, keeping x as a constant. So 6 by 7 constant வெளியில் எடுத்துடலாம். So we have to integrate this with respect to y. So 6 by 7 into x square is a constant, integral dy is y, plus x by 2 is a constant, integral of y வந்து y square by 2 between the limits 0 to 2. So here we have to substitute the limits for y. So 6 by 7 into x square is a constant, y க்கு upper limit substitute பண்ணோம்னா 2x square plus y க்கு upper limit 2 substitute பண்ணோம்னா 2 square is 4 by 4 is getting cancelled, so you get 2x square plus x minus the lower limit is 0. So the marginal density function of x is 6 by 7 into 2x square plus x. Now let us find the marginal density function of y. Fy of y is integrating the joint density function with respect to x. The joint density function is 6 by 7 into x square plus xy by 2. This has to be integrated with respect to x, and the limits for x is from 0 to 1. Let us integrate this with respect to x, treating y as a constant. So it is 6 by 7 into integral of x square is x cube by 3 plus y by 2 is a constant, integral of x is x square by 2 between the limits 0 to 1. So it is 6 by 7 into, substitute the upper limits for x. So when we substitute the upper limits, we get 1 by 3 plus y by 4 into 1 square is 1 minus the lower limit is 0. So it is 6 by 7 into, taking 12 as LCM, we get 4 plus 3y by 12. 6 and 12 it goes 2 times. So 1 by 14 into 4 plus 3y, where 0 less than or equal to y less than or equal to 2. We got fx of x is 6 by 7 into 2x square plus x, where 0 less than or equal to x less than or equal to 1. And fy of y equal to 1 by 14 into 4 plus 3y, where 0 less than or equal to y less than or equal to 2. Now let us find e of x. E of x is given by integral x into fx of x dx. So it is equal to integral x into 6 by 7 into 2x square plus x dx, where x varies from 0 to 1. So this is equal to 6 by 7 into, இப்போ இதை multiply பண்ணோம்னா 2x cube plus x square dx, where x varies from 0 to 1. இதை இப்போ with respect to x integrate பண்ணோம்னா 2 is a constant, integral of x cube வந்து x power 4 by 4 plus integral of x square வந்து x cube by 3 between the limits 0 to 1. So it is 6 by 7 into upper limit 1 substitute பண்ணோம்னா 2 by 4 plus 1 by 3, lower limit வந்து 0. So it is 6 by 7 into, taking 12 as LCM, so இது வந்து 6 plus 4 ஆயிடும். So 6 and 12 it goes 2 times. 6 plus 4 is 10 divided by 14. So this is equal to 5 by 7. So e of x equal to 5 by 7. Similarly, let us find e of y. E of y is integral y into fy of y dy, which is equal to integral y into fy of y is 1 by 14 into 4 plus 3y dy, where y varies from 0 to 2. Let us integrate this with respect to y. So it is integral 0 to 2, 4y plus 3y square dy, which is equal to 1 by 14. 4 is a constant. Integral of y is y square by 2 plus 3 is a constant. Integral of y square is y cube by 3 between the limits 0 to 2. So E of y is equal to 1 by 14 into 2 into 4 plus 8. So it is 16 by 14, which is equal to 8 by 7. So E of y is equal to 8 by 7. Now let us find what is p of x less than 1 by 2 comma y greater than 1 by 2. It is double integral f of x comma y dx dy. So it is double integral f of x comma y is 6 by 7 into x square plus xy by 2 dx dy, where the limits for x is, it is supposed to be less than half. So the lower limit for x is 0 to half, and the limit for y, it is greater than 1 by 2. So it is from 1 by 2 to the upper limit for y given in the problem is 2. So y varies from 1 by 2 to 2. So this has to be integrated first with respect to x and then with respect to y. So it is 6 by 7 integral 1 by 2 to 2. Integral of x square is x cube by 3 plus y by 2 is a constant. Integral of x is x square by 2 between the limits 0 to 1 by 2 dy. Now the limit has to be substituted for x. So it is 6 by 7 into integral 1 by 2 to 2, substituting the upper limit half, 1 by 2 cube is 1 by 8 by 3 plus y by 4 into 1 by 2 square, that is 1 by 4 into dy, because the lower limit is 0. So it is 6 by 7 integral 1 by 2 to 2, 1 by 24 plus y by 16 dy. So this is equal to 6 by 7. This has to be integrated with respect to y. 1 by 24 integral dy is y plus 1 by 16 integral of y is y square by 2 between the limits 1 by 2 to 2. So it is 6 by 7 into, let us substitute the upper limit, 1 by 24, y is 2, plus 1 by 32, y square is 4, minus the lower limit is 1 by 24 into, the lower limit is half, minus 1 by 32 into 1 by 4. So it is 6 by 7 into 2 by 24, 1 by 12, plus 4 by 32, 1 by 8, minus 1 by 48, minus 1 by 32 into 4 is 128. So this has to be simplified. So it is 6 by 7 into 1 by 12 plus 1 by 8 minus 1 by 48 minus 1 by 128. The LCM is 384. 12 goes 32 times in 384. So it is 32 plus 8 goes 48 times in 384. So plus 48 minus 48 goes 8 times in 384. So minus 8 minus 128 goes 3 times in 384. So minus 3. So 32 plus 48 minus 8 minus 3 becomes 69. So 6 by 7 into 69 divided by 384. So when we cancel by 6, it goes 64 times. So 69 divided by 64 into 7 is 448. So the probability that x less than half, comma y greater than 1 by 2 is given by 69 by 448.